FastMCP3 introduces a composable lifespan system that enables explicit wrapping of legacy context managers for seamless integration with modern lifespan handlers. This mechanism ensures backward compatibility while allowing precise control over initialization and teardown sequences. The upcoming code demonstrates how to wrap an existing @a ContextManager decorated lifespan using ContextManagerLifespan, enabling its composition with a new @lifespan decorated handler through the pipe operator. This pattern preserves execution order and context merging while maintaining clean separation between legacy and modern components.
From ContextLib import, async context manager. From FastMCP, server, lifespan import lifespan, context manager lifespan. @async context manager. Async def legacy lifespan server. Yield legacy, true. @lifespan. Async def new lifespan server. Yield new, true. Hash wrap the legacy lifespan explicitly for composition. Combined equals context manager lifespan legacy, lifespan new lifespan.
This code demonstrates how to integrate legacy lifespan management with FastMCP3's new composable lifespan system. The pattern shows explicit wrapping of an @async context manager-based lifespan using ContextManagerLifespan to enable composition with the newer @lifespan decorator pattern. The key mechanism involves creating two distinct lifespan handlers: legacy lifespan, using the traditional context manager approach, and new lifespan, using FastMCP's dedicated decorator. The critical step is wrapping the legacy handler with context manager lifespan before combining it with the new handler using the pipe operator. This composition creates a unified lifespan that executes both handlers in sequence, with their context dictionaries merged. This approach maintains backward compatibility while enabling modern lifespan composition features. The explicit wrapping serves as an adapter pattern, allowing older context manager-based lifespans to participate in FastMCP3's more structured lifespan composition system. The trade-off is the additional wrapping step, which provides clarity about which components are legacy versus modern, while ensuring consistent behavior across the lifespan lifecycle. Let's break it down.
From ContextLib import, async context manager.
Imports the async context manager decorator from Python's ContextLib module, which enables creating asynchronous context managers using generator functions.
From FastMCP, server, lifespan import lifespan, context manager lifespan.
Imports the lifespan function and context manager lifespan class from the FastMCP server lifespan module, enabling server startup shutdown lifecycle management and context-based resource handling.
@async context manager.
Imports the async context manager decorator from Python's ContextLib module, which enables creating asynchronous context managers for resource management in async code.
Async def legacy lifespan server.
Defines an asynchronous function named legacy lifespan that accepts a single parameter server. This function is designed to handle server-level setup and teardown operations, running once when the server starts and once when it stops, independent of client connections. The async keyword indicates it will perform non-blocking operations, and the server parameter suggests it will interact with the FastMCP server instance for initialization or cleanup tasks.
Yield legacy, true.
Yields a dictionary with a single key-value pair where legacy is set to true. This is typically used in generator functions to produce a value that can be consumed by the caller, indicating some legacy mode or compatibility flag is enabled. The yielded value will be available to the code that iterates over this generator.
@lifespan. Async def new lifespan server.
Defines an asynchronous lifespan handler function named newLifespan that takes a server parameter and is decorated with @lifespan. This function will execute during server startup and shutdown phases, with the decorator marking it as a lifespan event handler in the FastMCP framework. The server parameter provides access to the server instance for initialization and cleanup operations.
Yield new, true.
Yields a dictionary with a single key-value pair where new maps to the Boolean value true. This is typically used in generator functions to produce a sequence of values, with each yield statement emitting one value in the sequence. The yielded dictionary indicates a new state or condition, often used to signal that a new item or state has been created or encountered.
Combined equals context manager lifespan legacy, lifespan new lifespan.
Combines two lifespan objects into a single composable lifespan using the bitwise OR operator. The ContextManagerLifespan wraps the legacy lifespan and is merged with new lifespan, creating a unified lifespan that will execute both setup and teardown routines when the server starts and stops. The resulting combined lifespan will run all initialization and cleanup code from both lifespans in sequence. FastMCP3's composable lifespan system bridges legacy and modern patterns through explicit wrapping and composition. The legacy lifespan uses the traditional @async context manager decorator, yielding a context dictionary during server operation. Meanwhile, new lifespan adopts the framework's dedicated @lifespan decorator for structured lifecycle management. The critical integration happens when ContextManagerLifespan wraps the legacy handler, converting it into a composable unit. The pipe operator then merges this wrapped legacy lifespan with the modern handler, creating a unified sequence that executes both during startup and shutdown. This adapter pattern maintains backward compatibility while enforcing clear separation between old and new components. The trade-off is the explicit wrapping step, which adds clarity but requires intentional adaptation of legacy code. The result is a seamless lifespan chain where contexts merge and execution order is preserved, all while keeping the modernization path explicit and controlled.
The legacy lifespan whispers its context, while the new lifespan composes the server's future.